Goed, welkom iedereen welcome everyone in our last webinar of this year. At Smals Research, every year we investigate plenty of topics, and one of the topics for this past year has been AI-augmented software development in the broad sense. Now today I'm going to focus on the developer role, the coder role, and mostly talk about what AI can bring to coding. So on the agenda for today, small introduction. I'm gonna try a live demo. Live demos are risky. It might be that I'll need to improvise a few things, and I sincerely hope that ChatGPT hasn't changed the models overnight. I'm gonna give a small overview of generative AI in development tools, the state of the market, the state of the art a little bit. So how does it work in the back end? And things that need to be considered when you want to adopt these kind of solutions. Who am I to tell you about these things? Well, I'm not a full-time coder. Let me tell that first. I do have a degree in computer science, but my career has mostly been in research, academic and applied research. The programming languages that I know best are C++ and Python, and I'm traditionally a back-end developer more than a front-end developer. But I'm definitely not a super experienced developer. I'm mediocre at best. And that's actually quite handy because these kind of AI tools are, especially for developers like me, an enormous help. Because if I get to code, I spend lots and lots of time looking up things, reading up on knowledge that I might have forgotten. And these AI tools that suggest me a course of action really help me in getting to a good solution faster. Good, so let's dive in head first. I'm gonna open up my browser and let's go to ChatGPT. Let's maybe increase the font a little bit. Most of you know ChatGPT probably already. You've played around with it maybe. Let's ask a simple question first. Let's generate some data. If you need test data or a sample data set or something, it's quite easy to make ChatGPT generate a small data set, a table. You can actually see what's happening in the background. It's doing this by actually writing Python code and then executing it in the back. That's ChatGPT 4, by the way. 3.5 would maybe do it differently. And then afterwards, when we have this data, it'll display it to me and we can ask follow-up questions. The entire system is dialogue-based. It's a chat that you do. And let's already think about a question that we can ask based on this data table. Suppose this data table is a table that I have in a database somewhere. I need to write a query. I haven't touched SQL in years. I have no idea how to get started, but I know what I want to do. I want to make a SQL query that returns the average income of the people in this data set. And that's something that ChatGPT is fairly good at. These are rather simple questions, but if you need to get started with a new technology, then it really helps you get on the way without having to resort to reading entire manuals on how SQL actually works or entire documentation websites. I can make this a bit more complicated, of course, because this is like a one-liner, basically. But let's generate some Python code maybe that makes a plot. Now, plotting is one of these things that's hard to get correct. So also for these more complicated queries, ChatGPT will nowadays be able to come up with fairly good initial code. I say initial code because as a user, obviously you need to check whether the suggestion you got is actually decent, actually works and runs, because ChatGPT might suggest functions that don't exist, that are deprecated. etc., or might take a course of action that's not really the sort of course of action that you might have wanted to take. Maybe I wanted to use matplotlib instead of the Folium library, for example. In these cases, you ask follow-up questions until you get what you want. Now, in the later iterations of ChatGPT, there's also the possibility to add files. I'm gonna try and illustrate this with a piece of documentation coming from the Crossroad Bank's website on one of the services that they expose. So let's see, let's take I think the consult pension register, that would work. Let's open this. All right, and this document is a specification of a service that is provided by the Crossroad Banks of Social Security. And as you can see, it contains quite a lot of technical information and some diagrams. And what we can do with ChatGPT nowadays is, well, we can take one of these diagrams. Let's take this one, payments, back to the browser. And I can actually just paste this into my chat screen and then ask a question about this. So this diagram was the structure of an XML message, a communication that can happen. So I can ask, for example, to create a sample XML message that follows the structure outlined in this diagram. Let's say this diagram. And if everything goes well, but fingers crossed, it should at least give something that's roughly useful. Okay, give me an error. Let's try it again. But it got started well. It knows that in this diagram, it's all about payments. I have a list of payments. Each payment has a reference period, a total amount, an index, a history attached to it, etc. So this is all based on an analysis of the image. There's no guarantee that the result of ChatGPT is actually correct, but it can provide a good starting point. ChatGPT has the habit of doing lots of explanations, really point by point, explaining what it's doing and providing that way some transparency. Now, if I have an XML message, I can, of course, also ask it to create a Java class, for example, that can parse this structure. And in the same way as before, I could generate Python code, I can just as easily try and generate a Java class to parse this. Now, ChatGPT is an independent solution. You know exactly what you're uploading to it. You know exactly what you get back, but it's not really integrated in your IDE. It's not integrated in your environment. Nowadays, with GitHub Copilot, you can have similar functionality available in your IDE. There are other tools besides GitHub Copilot, but I'll come back to that later. And these tools will allow you to actually have a conversation with ChatGPT about your code, about your project within your IDE, and will allow you to copy paste this code, for example, in any open file in your IDE. So I think with this, we are done with ChatGPT. We know what it can do. Let's move to our IDE. Let's open a new file. And I can actually ask within the editor what I want to do. For example, well, maybe let's do the same thing. let's do something different. I want to write an algorithm. Let's also make it a bit more readable. Let's write an algorithm that takes as arguments an array of positive integers and finds the position of the largest subarray of 8 consecutive integers that have the largest sum. And it comes up with some code. It's a typical question. And there's quite a lot to say about this code. First and foremost, this hasn't been documented. Let's first accept this. This hasn't been documented. Maybe I want to add some documentation. Then I can just as easily ask it for documentations for, let's select the symbol, this function. It will add for me some documentation about it. If you look at what happens within the function, I have 2 nested for loops here. One is iterates over the array, and the other, for each element in the array, it's going to compute a subsum. This is a solution, but if you come up with this solution in an algorithms course at university, you will fail the course. Why? This is not the optimal solution. Actually, this is a very naive solution that doesn't scale very well. There is a better solution for that we can maybe ask. Can I open the chat window? Maybe that's easier. Yeah, let's open the chat window in the side. And let's ask for a better implementation or a more efficient implementation. Right, more efficient implementation of this code. Let's see what happens. Let's see if it can do it. It takes as the context the part of the code that I have selected. Also, when I wanted to create documentation, I select the part of code for which I want to create documentation. And GitHub Copilot tells me here that indeed the computational complexity of this implementation is of the order n times m, which is not ideal. I can do this with just a single for loop by actually implementing a sliding window. And each time I move one position forward in the array, I add the new number and I subtract the last number. And that way I can compute the sum of the subarray without having to recalculate the entire subarray sum. And that's, of course, much better. With this code that I have as a suggestion, I can immediately replace the old code. So I can insert at my cursor position, and hoppa, the new code is there. Let's see. This is JavaScript. So let's save this maybe first. Let's save this function in live demo.js. And let's try and use this and see if something useful comes out. I'm going to generate a new file, and I want to create a web page. Let's be more specific. That's always better. An HTML page that loads the live demo.js file. It's going to be something very simple, of course. What do I want to happen in this page? Well, in this page, like right here, okay, let's accept this right here. What do I want? Whoops. I want a form that allows to define an array, and I want a button so that when clicked, the function find largest subarray, is that the function? Yeah, find largest subarray from that file. It's live demo.js. .js is run, and I want the result displayed in the text field. I can actually also, I have a function here to synthesize multiple solutions, to generate multiple solutions here. By default, Copilot will come up with 10 suggestions. I can select which suggestion best suits my needs and then go further from that. So I don't know, I don't really have time to evaluate in detail, but suggestion 3 here looks fairly decent. Let's try this one. Let's save as live demo.html and see what happens. Can I serve this? Yeah. It does something, it's maybe not correct. Yeah, it fills up the array itself. Find the largest subarray. Doesn't do much, but you get the gist. By iterating and iterating and iterating, I can actually try and improve on this and come to a solution much faster than when I would have typed this manually. Good. Here I'm going to conclude the live demo because I'm already 20 minutes in and there's lots of other things to talk about. Back to the presentation. Some upsides, some downsides that we could see. First and foremost, these kind of tools, these plugins that help you write code, they can quickly make relevant or even novel suggestions. Maybe they use libraries or algorithms or functions that you haven't heard about before. And so they help you to get started much faster. They can not only help you generate code, but also the tests that accompany them or the documentation that needs to accompany them. That also works for text. The best way to use them is to try and divide your task, your problem, in smaller subtasks. The smaller the task it needs to do, the more the chance you have that the result is going to be good. It works best with commonly used programming languages, so Java, JavaScript, Python, usually not a problem. If you do something with more exotic languages, you might run into some trouble because it doesn't know the syntax and the habits of those rare languages as well. So it's good to get started to write boilerplate code, and it's actually fairly easy to learn to use. You just have a few shortcuts in your editor that you need to learn to call up those chat screens or those suggestion screens. And nowadays you can even work within the editor itself with a tooltip. But once you know these shortcuts, you're good to go. We need to keep in mind, though, there are some drawbacks as well. The suggestions you get are hallucinated, and they're not logically deduced. I'll go more into detail later. So there are actually no guarantees on correctness or fitness for purpose. And the first try, as with trying to compile for the first time some code, it usually won't work from the first try. You need to try and refine, dive deeper into it, really enter into a conversation, let's say, about the code to try and put the dots on the I. Because the replies and the suggestions that you get from these systems are hallucinated, you can ask it multiple times the same question and still get different responses. And actually, GitHub Copilot itself will come up with 10 different suggestions between which you can choose. It may also suggest deprecated functions, suboptimal code. As we've seen, we got a very naive implementation there the first time. It may actually try and propose solutions that use bad practices. It might propose solutions that are very complicated or almost incomprehensible, cryptic kind of code. And that's a risk because you might need to debug that kind of code. Something important to keep in mind is that ChatGPT is going to mimic whatever's present in the editor. And that means it's not going to come up with the best solution. It is going to come up with solutions or suggestions that follow the style of code that have been used in the project before. So if you have a good coding style, then you're going to get good coding suggestions. If you are a very advanced developer and you use very advanced functionality of a programming language, you might get very advanced you might get suggestions that use very advanced constructions. But anytime, every time, it's going to try and mimic the code that's already present rather than come up with what could be the best solution. So it's very important to keep a very strong oversight and to have a strong testing and validation process in the background. Don't just accept this code as is. All the code that comes out of this, all the code that's generated should be validated, tested, read, and understood. That's the most important takeaways, let's say, in general. Good, let's take a look at the tools that exist nowadays. Basically, you can divide the families of language models that are behind these tools in two different families. First and foremost, there are the language models that do text completion in the case of code completion, and also code infilling, like filling in a function in the middle when you have some code preceding it and some code following it. These are classical text continuation models. They already exist for a long time. And in generally, those are trained on masked text. For code, what can we do? We can fill in a function. We can continue an incomplete piece of code. We can write a comment that follows a particular piece of code, or write some code according to a particular comment. Now, chat is something different. If you want to do chat, you don't want to complete or add to an existing text. No, you actually want to reply. And this is the same difference as with prose, as the text of a play is compared to the text of just a normal book, let's say. So these systems are trained differently. They're trained based on dialogues, based on question response, based on data sets such as Stack Overflow. And they incorporate some human feedback. The technical term is reinforcement learning through human feedback. We're not going to dive deeper into it, but those data sets are harder to collect, but they give you the ability to actually talk to your system. And that's usually a different class of model. For codes, what kind of questions, questions can you solve with them? Well, you can reply to statements that are formatted as a question. You can ask actual questions like, how could this code be improved? Write some code, write some config file, write a query, write whatever, but you basically give an instruction and the model will reply to you. Now, so traditionally, those are two different classes of models. You will have to see them separately, but starting this year, we've really seen that they start to be merged. And nowadays, in GitHub Copilot in the backend, it's very likely that there's only a dialogue model, only a chat model present, and no longer a separate code completion or code infilling problem. But it's a closed source system. I don't know exactly what's in the backend. So GitHub Copilot, I've talked a lot about it, why they were the first to actually come up with a solution that was well integrated and quite performant. Initially, it was based on a separate model that they've based off GPT-3 called OpenAI Codex, but since March this year, they've deprecated that model and now use a chat completion model, so a chat-based model instead. So if you have used GitHub Copilot in the past, in March 23 or earlier, Nowadays, the results you get back will be quite different compared to that previous version. You might want to try again if you had been disappointed before. What can you do? Generate code from comments, complete your next line, complete a function, offer new knowledge, such as finding a useful library, add comments to the code, and eventually rewrite code for better efficiency, better readability, better whatever. Something that's also useful, for example, is if you want to optimize something for speed, you can ask to write part of the code such that it uses particular CPU instructions, for example. You can really dive deep with these kind of things. So if you look at how this was received among developers, in general, the sentiment is fairly good. Stack Overflow in this year, they've made a survey. They do it regularly. They made a survey, a developer survey, and they've asked developers about their stance about AI tools as part of the development workflow. And most coders, beginners that learn to code, as well as professionals, senior developers, have a quite favorable attitude towards these kind of tools. If you look at the benefits that developers hope to achieve, then we see that for junior developers, they really want to improve accuracy and get a greater efficiency, increase productivity, while for professional developers, that is less the case. They might be more concerned with productivity, but improving accuracy for them is less of an issue. They know how to write accurate code already. And speeding up learning for them is also not really an issue, because if you're senior, you usually already know your shit. Now, GitHub Copilot, GitHub itself, of course, also published some numbers. Maybe these are to be taken with a little grain of salt because they're self-published and self-reported. They might be selective, but even if it's anecdotal, it counts for something, maybe. Most developers that use GitHub Copilot do say that they feel they become more productive, are more fulfilled, and feel like they're better able to focus on the core business of their job. Now, if you look a bit more into detail in the Stack Overflow developer survey, and you look at different tasks that need to be performed in by a developer, there's learning about the code base, project planning, writing code, etc., etc. Then you see that nowadays, for writing code at least, these tools are being adopted by virtually everyone. So over 80% of the respondents says that they've already used this for writing, while there's still a gap, for example, in project planning. Very few people have tried to use these kind of tools for planning purposes, but they're nevertheless very interested in using them. Today, the focus is on code mostly, so I'm not really going to dive into the details about tools that exist for project planning, but whoever is interested, there's a really good website called there'sanai4that.com. If you're looking for something new and you want to try an experiment, go try and look for an AI tool on that website that does more or less what you want to do, and try and experiment a bit for yourself. It's a very interesting exercise. Also for testing code, we see that right nowadays it's not used as much as it could be. Nevertheless, there's a lot of interest. So also testing code is one of these big things that's in which we are probably going to see a large explosion of new AI tools popping up this year, in the next few years coming up. Copilot is not the only player on the field. There are quite a few other providers. The market is fully open, and there's lots of things being tried out, lots of startups being founded. This is already a fairly old table, dates from May in this year, that gives an overview of some alternatives to GitHub Copilot. And what's nice about this table is that they also clarify some things that you might want to keep in mind when you need to pick and choose the solution that you want to adopt. Especially in our context, it might be important that we have, for example, a self-hosting option. Not all providers do that. GitHub Copilot cannot be self-hosted, but there are options that allow self-hosting, then not with a GitHub Copilot or maybe with Git, of course, but with other models. But there are plenty alternatives. There are solutions that can be fine-tuned on your own code base. Now, fine-tuning is very complicated, so I'm not sure if for a code base of the size and the breadth of Smals, that would be a good solution. And maybe it's important to you whether a solution is open source or not, or that the price is right. In any case, these kind of tables would deserve an update, and I would believe that also other companies like a Deloitte or a Gartner keep a very close track of these kind of properties for all of the providers. There are alternatives in the open source world. A couple of interesting ones. Phopilot maybe was the first, but the last that I could see of it, it was there haven't been commits in the past 6 months or something, so I do have a feeling that the project is abandoned. It was interesting though, because you could use the existing Copilot plugin in Visual Studio or in IntelliJ IDEA and basically change the backend. So as long as you have your own backend server running somewhere with a code creation model, you could actually hook it up to the existing GitHub Copilot plugin. Whether that works after 6 months today still, I do not know and I cannot guarantee. Projects that are active are Tabby, which really is meant to have a self-hosted open source and on-premise alternative to GitHub Copilot. There are the LLM projects that are developed by Hugging Face. So Hugging Face has centered very much about the around the open source Starcoder alternative first, but now has opened up a bit, and their plugins now also support alternative open source models. And the good thing about this one is they include a plagiarism checker. Handy, because if you receive a suggestion, you might want to know whether that suggestion isn't by accident derived from some code that had been found online and was copyrighted. So this is some very interesting functionality there. And the most active project right now that I think is maybe continue.dev, which is a generic plugin that you can use with commercial and with open source models that you deploy either locally or on some external service about which you have full control, let's say like a replicate.ai, or on a private instance of a private virtual server, let's say on AWS, Google Cloud, or Azure. There are undoubtedly more than just these four, but in my personal opinion, these are the more interesting ones right now. Things can change quickly, so it could be that tomorrow I'll need to swallow my words and tell something differently. How to pick and choose a backend, how to pick and choose a language model. For open source models, there are leaderboards. And actually, I can maybe just see what the status is right now, because you never know. There might have been leaderboards that have appeared yesterday night or something, and then my slide is outdated. So this is the state of this leaderboard right now, where the most performing code generation model based on the human eval and multiple E benchmarks is the FIND model, which is an instruction-tuned model, so it's a chat model, scoring quite well for Python and not too bad for Java. The first code completion model, like a base model, is Code Llama at the moment. That's this green button. So based on this, you can actually try and choose a model. If you want to self-host, you want a model that doesn't have too many parameters. 34 billion parameters is something that doesn't really fit in the memory of modern common hardware, let's say, off-the-shelf hardware. It won't run on your laptop. 7 billion parameter models, those are manageable. And the DeepSeek model is the first one here in the benchmark with good results for a smaller model, like a 7 billion parameter model you can fit in memory on your laptop, actually. Good. Where's my slide? Hoppa. Good. Commercial providers, they report their own numbers. Like before with the data that GitHub provided about the Copilot, if Microsoft tells you something about their model Phi 2 that has been released 2 days ago, you also have to consider this as selective data, and these benchmarks cannot necessarily be reproduced. But at least Microsoft claims with Phi 2 that they have the best smaller model right now that can also do some coding, actually performs quite well on the coding benchmark. And their biggest competitor is Google Gemini. It came out last week in a quite controversial way, let's say, because there are some questions about the truthfulness of their demonstration. They do report Microsoft's better numbers on at least these 4 benchmarks. That's not all benchmarks that exist on these 4 benchmarks compared to Google's Gemini. Good. How does this work in the backend? Large language models are at the core of these systems, and large language models, they predict plausible next words. And actually, maybe that's also something that I can show in real life. Where is the link? Yeah. Nope, that's not it. Ah, I lost it. Never mind. What these models do is generate the next plausible words. And if you actually try this out in the OpenAI playground, you can get a good view. There's an option here to show the probabilities, where you can actually see that even if you ask to generate code, that code is generated in a probabilistic way. So here, a piece of code that inverts a string, even the way to access a character in a string was probabilistically decided. There was an 80% chance that the code suggestion would use square brackets, but there was also a 20% chance that it might have suggested the char_at function. Just to keep in mind, these models don't give you the suggestions based on logic. They give you the suggestions based on probabilistic, based on a pure chance. And any logic, any determinism, or any reasoning that needs to happen with these models must be added around the LLM in code that surrounds it, in pre-processing, in post-processing, or in any sort of handling of the response, or handling of the query, compiling of the query that you do beforehand. The LLM itself also today, also for code, works probabilistically, and the replies and the suggestions you get are basically one big result of one big lottery. A lottery, of course, that takes into account the context and makes it more probable that you get relevant results. Nevertheless, still a lottery. These models, if they work for code, don't work as well for every language. I'm not going to dive deeper into this because this is one of those enormous tables. But this is just to make a point that whatever is a good model for Java is not necessarily a good model for C++ or C# or shell scripts or whatever. ChatGPT is fairly good in quite a lot of things. But nowadays, we also see a trend for smaller models, like the Phi 2 model of Microsoft was trained or specialized mostly for Python and will perform way better, way worse in other languages, for example. So this really depends model for model, which is the best for which language. And you might actually want to change models or pick a different model based on the language you program in. It's important to know that code is not the same as text, and language models, generic language models that produce text, they benefit if they are adapted or tailored or fine-tuned to the specificities of computer code. What do we want to do with a data set of computer code in order to make a model work better? We want to annotate it. We want to add some information, some side information in the form of, for example, signaling tokens. These can be very simple things. For example, markers that say here starts the code, here starts the comment, here starts a variable. This is a block of code that can be run. This is a function. This is a procedure. This is a class. That can be very simple things. But we are going to add this to the code base, to the training code. We're going to fine tune a language model, a default language model for that, and it will become better to generate code. The reason for that is that you basically are going to be able to much better ground it in the logic, in the structure that is inherent in these files. This has some side effects. Mostly that an IDE plugin may need to do some similar pre-processing on the code that's present in the files that you have opened in your IDE before it can actually cook up a query, send it to the model, and get a response. It might also receive these kind of additional tokens in the reply and would then need to be able to process it. So an IDE plugin that hooks into a specialized model like this needs to do quite some lifting by itself. This is not just, let's send the query. No, there's quite some pre-processing and post-processing that needs to happen. Likewise, each model, each dataset, has might have a different way of tokenizing, of adding those different tokens, those additional tokens. So if you change models, you might also need to change tokenizers in whatever plugin you use in your IDE. What happens behind the scenes? Well, the Copilot plugin has been reverse engineered. And what happens when we want to send a request for suggestions to GitHub Copilot through the plugin in Visual Studio or IntelliJ is this. First and foremost, we're going to collect data. That data consists of the parameters, like what is our current document, what's the position of our cursor, where are we, what's the selected text, like that we want to ask a question about, what's the language we're programming in, what's the path on our file system, etc., etc. And then it's going to collect a few other things. It's going to define a scope. And the scope in GitHub Copilot is defined as the 20 most recently accessed files. And it's going to search in those files for relevant snippets of code in order to build up its knowledge of your code base so that it can actually come up with suggestions that are tailored to your code base as is, but not the entire code base, just the 20 most recently accessed files. If the information it needs is not in there, you might get weird results. To select those snippets that are relevant, it's using a few heuristics. It has been found nowadays that it uses a sliding window with a Jacquard similarity. It's like a string similarity metric to make sure that it, for example, has the declarations of all the variables that might be used in the piece of code that you've selected, and so on. Once it has all the relevant snippets, it's going to reorder these, fill up a prompt, like the instruction that it needs to send to the model, and it's once that prompt has been constructed, it's going to send it to the model, receive the results. There's some filtering that happens afterwards because you might get nonsensical results, very repetitive results, results that are maybe in the wrong programming language, could happen. So after that filtering, it can only display the suggestions to the user. So this is actually an instance without going too deep in it. Oh yeah, one more thing, more important before I forget it. GitHub Copilot is a commercial solution. Once you accept a solution, a suggestion, and you import it in your code base, it's gonna send some telemetry back to GitHub. What is it gonna do? It wants to know whether the solution you accepted is also on the long term a good solution. So it's gonna check. After 15 seconds, is that piece of code still there? After 30 seconds, after 1 minute, after 2 minutes? Or have there happened any changes in the suggested code? And in this way, GitHub is collecting data in order to further improve their existing models. So this telemetry, that's an option that you can actually switch off. And in open source models or stuff that you self-host, of course, you have full control yourself over what kind of things is happening. Usually you won't have this kind of telemetry happening, but GitHub Copilot does it. So this kind of system, it's basically an instance of retrieval augmented generation. So we have a question here, fill in a function, write a test case. We're going to retrieve relevant text or code snippets from our code base that has been indexed, most likely in a vector store, could be some other store, or at least internally made. Relevant snippets are collected, a prompt is constructed that contains the question and the relevant data points, and then the language model, whether it's Copilot, whether it's Code Llama or Code Whisperer, whatever, will generate suggestions. So this is an instance of that same kind of system that is used nowadays, that's very popular nowadays, and used to ground the hallucinations in current data and in current context. Good. I don't have much time left, but just a few more things. I'm not going to read this slide out. I've made a little SWOT analysis of strengths, weaknesses, opportunities, and threats. So in the short term, strengths and weaknesses, I've talked quite a lot about it. I've illustrated a few things. But on the long term, there are some opportunities and threats that maybe are worth talking about for these last 10 minutes. First and foremost, correctness. Correctness remains a point of attention. Like I've said before, these things hallucinate by default. There is no guarantee for correctness. It could be that tomorrow the model in the backend changes, or whatever, and anything behavioral that you relied on might not be valid anymore, and you might get nonsensical answers. Therefore, you always need to keep an eye on correctness, validate whatever comes out of these things, test and review. Productivity. Do these things make you actually more productive? Well, there the takeaway is your mileage may vary. Code writing in itself is a small part of the time spent on a project, and most developers don't write all that much. They don't write 6 out of 7 hours or 7 hours 48 minutes nowadays. So that's one thing. Second, we need to keep in mind that time gained coding may be lost again because the suggestions that we have accepted may contain errors, may be complicated, may need deciphering, are complicated to understand, require more debugging. And if we look at, well, can we quantify this? How much more productive can you get? Well, it's really hard to quantify this. Up till now, there have been only a handful of studies that try to put some numbers on it, and the measurements are mostly anecdotal. So let's first say GitHub, of course, on the right hand side, they say like, oh, you can get up to let's say 50% more productivity, but they say in the same time the confidence interval is between 20% and 90%. That's an enormous confidence interval, and it's their own report, so I would take it with a grain of salt. It's also only about the coding, so it doesn't take the entire project and the architecture and the project management tasks and whatever into account. An interesting study also was done by this guy, Vaitilingam, who basically asked his students to try a task. Well, he divided his class into two groups. One could use Copilot and one could use the standard IntelliSense code completion, and see what this gives. And it turns out that the results vary enormously for each individual. There are people who can solve easy tasks much faster with Copilot, but once you give them a slightly harder task, Copilot actually makes it much harder to come to a good solution, because they are led astray by a wrong suggestion or by not understanding what they are suggested, etc., etc., and they actually lose more time than what they would have lost if they try to do it without and try to use themselves. So this is a very personal experience. It's why I say your mileage may vary. You need to test and try for yourself whether you have some benefits for these kind of tools, and be quite judicious where you apply. Do not blindly do this and say, oh, this is going to improve everything all the time. That's definitely not the case. There are some, it's a very personal, yeah, like everything that has to do with the development environment, it's a very personal experience. Then intellectual property. There is some yeah, legal dispute, let's say, about the validity of GitHub Copilot, mainly because it's not really known on which data it was trained. Well, data comes from GitHub, but GitHub also has code with licenses that are not permissive. And yeah, Microsoft keeps its mouth shut as to whether that code was included. Yes or no, but it's kind of likely it was, at least in the first iterations of GitHub Copilot. The legality of these copyright issues, it's way much to take, but I'm just going to refer, way much to talk about now, but I'm just going to refer to an interesting article on HackerNoon here. It's an article in 37 chapters that basically lays out the entire dispute. Copyright and ownership. So there is some AI-specific legislation coming, but it comes slowly. Like the AI Act was only, well, the start of the AI Act, let's say, was only approved formally in the past week. But in the meantime, there are already laws that exist, and the existing law is in full effect, and that does provide some guarantees and whatnot. The current prevailing opinion, but I'm not a legal scholar, let me say that first, but my gist is that the current prevailing opinion is that only humans can claim patent rights. At least for the European Union, that's been decided by the Patent Office. And in the US, there's a research service report that talks about copyrights. Now, in the EU and US, copyright is slightly different. In the EU, there's requirements for copyright. that the copyrights can only be given if there's an original contribution through intellectual creation. And then we end up with a debate in what sense is a large language model that spits out suggestions, in what sense is that an intellectual creation, yes or not? That's an endless debate. I'm not going to amuse you with this. The most important things for you as a user is to check the terms and conditions very carefully, because they may grant to GitHub Copilot or whatever provider you use a license to reuse whatever you send to them. And they may also demand that you have full custody, full rights to share and distribute anything that you might submit. And that's quite a strong requirement. If you have doubts, you contact your legal department. At least with us in Smals, they're on top of the case. I'm going to skip this for time reasons. You can look at the Microsoft terms and conditions as an example if you want. Last but not least, security. Do these tools generate actually secure code that is free of buffer flows, free of SQL injections, free of whatever kind of vulnerability? Generally, no. You have no guarantee that the suggested code is safe in any way. And there is also a benchmark for that. And the most important conclusion you can draw for that is that if you have a better model, say you use GitHub Copilot, you get more syntactically correct codes, but almost no more secure code, no code that's any secure. Why? Because it really patches itself on the existing code base, and it's really not made to create code or validate code for security. That's something that you need to do yourself afterwards. So we actually see that GitHub Copilot, when it comes to creating code, there are actually models that do slightly better on this particular benchmark. So that's also a caveat, let's say. Good. So I don't think we need to be afraid that AI is going to replace us anytime soon. The amount of validation that's necessary is insane. Humans are still necessary in the loop. I do like a quote that IBM has put in one of their reports about this new technology and this new trend. It's that people who use AI will replace people who don't. I'm going to add people who use AI judiciously and wisely, because as shown before, you can actually lose time with AI as well. So you need to use AI in a way that it actually helps you, and try and avoid anything that might distract you or send you down the wrong path. In any case, Pandora's box is open, and AI assistants will become part of default Office software. Microsoft is going full speed ahead with that. So what we may see also for the job markets, well, the job content of developers, is that there might be a shift that happens where we need to do less writing, less coding ourselves, but then in exchange, more reviewing of code that has been suggested. Good. Conclusion. It's 3 o'clock. I'm going to try and be fast with this. My general feeling is that soon coding without an assistant will feel like writing a text without a spell checker. If I need to write a text, I'm Dutch speaking. If I need to write a text in French without a spell checker, I'm absolutely lost. I need this in order to be productive in French. And we're roughly going in the same direction. That's my gut feeling, let's say, with these kind of tools, these coding assistants. The closed source models are better, but the open source models are catching up, or at least following suit. Though they don't have the means that a Microsoft or an OpenAI has, but they're going in different directions. They're looking in different directions for different optimizations, smaller models, specialized models, better dataset quality, etc. There are leaderboards if you want to keep track of the latest and greatest, and keep in mind, avoid over-reliance, keep on top of things. Know that your full code base is shared with the coding assistant, so don't use these tools if there's anything private in your code base, anything that might be a security leak or whatever. You get the best results working incrementally. You still have to treat the results with caution, and there are no guarantees. So, good practices. Don't put sensitive information in any files that are to be read by a coding assistant. If you use GitHub Copilot, if you use Code Llama, Code Whisperer, Tabby, whatever, no personal information, no keys, no tokens, no credentials, no access codes, no passwords anywhere in your code base. That's good practice anyway, but do double check before you're going to adopt these tools that it's the case. You may want to mark generated code as such, not only for eventual copyright reasons later, but also to make sure that you know which parts of the code you need to test and validate double as good. So review documents, test everything, way more than you did before, especially if you're going to do generated code. Don't accept anything you don't understand, and adhere to high standards. If your existing code base is garbage, Copilot is going to suggest you garbage. So garbage in is garbage out also counts for code generators. Good. What's happening at Smals? So the general idea at Smals is, yeah, cool. We can't stay behind. This is something that's happening very fast. It's coming. Microsoft is pushing this. There's already a Copilot in the Edge browser. It's going to come in Word, Excel, whatever, in Microsoft Teams. There are already plugins that are Copilot compatible. So this is coming, and this cannot be stopped. But we need to adopt these kind of tools wisely. We need to be aware of all the caveats of all the downsides. Some first guidelines have already been communicated to you. There is going to be a new competence center soon. The first task that's going to happen, like what's happening right now, is basically there's an inventory of tools that have been used. I'm sure that every one of you has been experimenting themselves a bit. Do let them know the good things, the bad things. It may be good to make a selection as well. Let it know and send whatever tools that you've experimented with to generative AI govboard@smals.be. That's going to be the generic email address to contact the generative AI initiatives that are going to be deployed at Smals. And for next year, there are plans to do a pilot with test licenses for a coding assistant in a developer's team, and there's a pilot or a proof of concept at least planned with AI tools for other functions within the development lifecycle. So with AI tools that can help project managers and analysts. Those are things that I haven't treated today, but obviously also for them, plugins, generative AI plugins are coming. It's moving fast. Developments in the last 2 weeks have been insane. Mistral, the French startup company, has released a new mixture model. There are smaller and condensed and specialized models. So first, Google came with Gemini. Then 2 days ago, Microsoft came with Phi 2. There are new initiatives being started to improve reproducibility. Microsoft has an initiative to do better prompt engineering. A new prompt database specifically might be interesting for medical purposes here. Though I would be very careful with medical things in generative AI. There are new directions being researched. For example, prompt compression, fine-tuning with generating data, etc., etc. The function calling that is now available in ChatGPT, for example, is also coming to open source projects through libraries such as Gorilla Open Functions. Others might exist already that I don't know of. The AI Act is moving forward, and there are several new institutes and alliances being formed. This is from the past 2 weeks. You understand that this goes so fast that we at the research department at Smals are barely able to keep up. And actually, well, we have to say it the way it is. We cannot keep up the way it is. So I do invite you all, if you're interested in this, to start explore yourself, get a feel about these technologies, and try and develop a sense of what they can do for you, how they work, and keeping all the stuff that I've been talking about in mind while you do so. Because I cannot do this alone, and we at Research, we cannot do this alone. We need everyone to be to explore and to explore a bit further. Good. So for next year, what will we see? Yeah, Copilot in everything. Yeah, that's going to be the theme for 2024, undoubtedly. Already there's an integration in Microsoft Teams. You can create your own Copilot-powered plugins for anything that you do with Teams. GitHub has Copilot Workspace in the making, which is basically gonna integrate this with other parts of the workflow. So you're gonna have an issue in your code base that you can actually ask to generate an entire plan towards a solution, and then point by point implement this plan with code generation. That's coming. So it's going to be further integrated, where now these tools are still very individually in their particular applications. We'll see it much broader deployed and also usable in entire workflows, in entire workspaces, let's say. There are still many issues with that because all those plugins, all those technologies, there's not really standardization in place. They are mostly mutually incompatible, and communication between these plugins, there are no standards about that whatsoever. So this is all being developed as we speak, but definitely next year we'll see this. We'll see large strides forward. Good, that was it for me. Thank you for listening.